Imagine waking up one morning to find out that your child has a rare genetic disease that has no cure. And doctors say that there is small molecular tools that called CRISPR-Cas9 that might have a power to fix that gene, like fixing a typo in a sentence. My name is Muhammad Rafahat bin Muhammad Yusof. My metric number BBT 12240017, and today I'll be guiding you through the fascinating world of CRISPR-Cas9, how it works, how it functions, how it changed life, and how it cures some of the humanity's most devastating disease. By the end of this video, I hope that people will understand the basic concept and mechanism of CRISPR-Cas9, and they can recognize the medical significance and the potential of CRISPR-Cas9 technology. First of all, we have to know what is DNA. DNA stands for deoxyribonucleic acid, that is like a blueprint of our life, made of 4 letter A, T, C, G, and like instruction book for our body. DNA carries the genes that determine how we look and function. For example, like our eye and skin color and hair types. This is DNA. And what are genes? This is DNA. Genes are a small section of DNA that carry instruction to make proteins. These proteins that perform most of the work in our cell and bodies. Mutation in genes can cause a disease, for example like diabetes, cancer, and also thalassemia. And what is genome or genome editing? Genome is all the DNA in an organism. Genome editing is the making change to the DNA sequence. Genome editing is a technique that allows scientists to make a change in the DNA sequence. For example, like this DNA that have mutation in it. So genome editing allows the scientists to delete, insert, or replace this piece of DNA so that the person can live a happy life. Alright, so we're gonna dive deep into the CRISPR-Cas9. What is CRISPR? CRISPR stands for cluster regularly interspaced short palindromic repeats. First, CRISPR is originally found in the bacteria as a defense system. Bacteria, they store like a memories of past virus attacks, like a wanted list lah. So they will kind of fight back lah. So because they already know the virus, right? Cas9. Cas9 is a DNA cutting protein. It is an enzyme that works with CRISPR. They're like a scissor that guided by a map. So it can cut DNA at a specific location chosen by a scientist. So now let's see how CRISPR-Cas9 works. The first step, we will find the problem. A special molecule called guide RNA is like a GPS, gRNA. They search the DNA and to find the faulty or damaged gene, like we said earlier, that cause the mutation, the part that we want to fix lah. The second step is they lock onto the target. Once the gRNA find the matching DNA sequence, they lock into it like a puzzle piece fitting perfectly. This helps CRISPR know exactly where to make a cut, so they can cut the gene. Step number 3, cutting the DNA. Then comes Cas9, the thing that we call as a scissor. They cut the DNA right at the spot where the gRNA pointed to remove the DNA. And the last step is fixing the DNA. After the DNA is cut, the cell try to repair it. There are 3 possible outcomes. First is delete the faulty part. The second one is insert new correct DNA. And the last one is change the existing code slightly, the mutation lah. This repair process depends on how scientists program the CRISPR system. So in the simplest way to understand about this is CRISPR works like a smart GPS and a pair of scissors. They find a mistake in our DNA that causing the mutation. They cut it out and help to fix it, just like editing a sentence in a document. After the CRISPR-Cas9 cut the DNA, our cell try to fix it. We can do it in 2 ways, like using a different type of glue. The first one is NHEJ. The second one is HDR. NHEJ stands for non-homologous end joining. This is like a quick super glue. You just take the broken ends of DNA without checking if anything is missing. It's fast and the cell uses it most often, but it's quite messy. We might leave out piece or add extra one, which can cause a mutation. The second one, we have HDR, homology directed repair. This one is like a careful repair using a blueprint. They do it like using a template, they measure a piece of DNA to repair the break properly. This way, it is much more accurate, but it works well only in a certain situation and slower than NHEJ. To fix the cut, they said either use the fast glue and risk mistake or follow proper instruction guide by the scientist for a clean fix, which they are. Scientists can choose which method to use depending on the goal lah, whether to remove a gene, fix or replace it. So now let's move to the disease, to the clinical case study, LCA10, which stands for Leber Congenital Amaurosis Type 10, a disease that related with the mutation. LCA10 is caused by a mutation and in a specific gene called CEP290. CEP290, they help our eye cell, like a photoreceptor, work properly. But in LCA10 patient, the mutation breaks this function, leading to vision loss or blindness in early life. What is the function of CRISPR-Cas9 in this situation? Scientists are now using CRISPR-Cas9 to go inside the eye and directly edit the CEP290 gene. Remove the mutation so that the gene can work normally again. The CRISPR treatment is called Edit 101 and is part of the real clinical trial. One of the first time CRISPR is being used directly inside the human body. So this is kind of the risky trial for human. LCA10 is more than just a rare eye disease. It's a gateway to the future of medicine because for the first time ever, CRISPR is being used to go inside a living person's eye and try to fix that gene that causing the blindness. So, relating the disease and the treatment that we say just now, there is a company called Editas Medicine invented Edit 101. They're trying a new way to help blind people to see again that relate with the LCA10 disease lah. They started this test in 2020 and still happening until now. They gave a special injection into one eye of a blind person. This injection has something called Edit 101, which is meant to fix the broken gene that caused the blindness. What is the patient outcomes from this treatment? This is the first patient to be treated by a CRISPR-Cas9 by receiving Edit 101 injection into one of their eye. And the good thing is they show some improvement in light perception, no serious side effect. And CRISPR-Cas9 is the first ever in vivo CRISPR tried in humans milestone in genetic medicine. As we've seen, CRISPR-Cas9 can do amazing things like fixing genes to help blind people see again. But there's a big question that we have to think about. What if people start using this tool not just to cure disease, but to change things like height, intelligence, and appearance? Isn't that going too far? Are we starting to design humans? CRISPR has the power to save life, and it's beautiful. But when it comes to changing traits like looks or IQ, you need to be very careful because science should help us to live better, not to make us feel like we need to be perfect. That's all from me. Thank you so much and see you again in the next presentation video. Assalamualaikum and goodbye.